So the first thing we're going to start off with is writing an augmented matrix. An augmented matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and n columns are read as m by n. M rows by n columns. So the dimensions of matrix A here is 2 by 3. 2 rows, 3 columns. And the numbers inside of it are considered elements. Now, most likely we will come back around to matrices and go more in depth than what we're going to do today and to Monday and Tuesday. We'll go more in depth because we'll look at the basics of dealing with this here, solving or writing augmented matrix and solving them with row reduced echelon form. And then Monday we'll talk about addition, subtraction, scalars. We won't hit multiplication, and there is no division. We don't divide matrices. But there's other things that we can do with them. And we'll delve into that more at a different date. We'll use a different book. Because the books that we had before this one here actually delved into matrices and had a whole unit on matrices. So we'll cover that eventually, and I'll have you use those textbooks for that, and then you'll appreciate the textbooks that we do have. And I think for some of you who don't have it, I'm going to look into it. I think we might have some books in one of the other classrooms, I just realized. So we have those there. The other books are about twice as thick. They're about yay. And we'll use those for them. Now, you don't have to write this next part down, but when we have a system of equations, like yesterday and the day before, we had it written out like this here. If I want to write it as a augmented matrix, we take the coefficients. Y'all remember what coefficients are? The numbers in front of the variables and the variables. So if you notice that the top one here, 5, 3, negative 2, 1, 5, 3, negative 2, 1. 1, 2, 3, negative 1, 1, 2, 3, negative 1. 3, negative 4, 1, 3, negative 4, 1, 10 are written like that there. Also grab a highlighter. And if we notice X, X's numbers. Y's, Y's numbers. Z, Z's numbers. And then our constant terms all line up like that there. And they do that on purpose. And we want to line them up. So no matter what the variables are, most of the time we'll get X, Y, Z. We want X, Y, Z. And that's really just going back to number theory. Number theory pretty much states we want it in alphabetical order from left to right and in order of descending power. Biggest power goes first, smallest power goes last, and we always want it in alphabetical order. Okay? And that's what we have. Before you write an augmented matrix, make sure the equations in the system is written in standard form, including zeros for the coefficients of any missing variables. Now, if it only has X and Y in all three, then we just need X and Y. We don't need X, Y, Z. If two of them have X, Y, if X, Y, and Z appear at least once in all three, we need X, Y, Z placeholders in all three. So if one is missing, that's fine. But if we just have two equations with X, Y, we don't need Z. We only need it if it is listed at least once. Okay? So let's look at the first example here. So it said that we need to write each one in standard form. Is this top equation in standard form? Well, no. What's first? Y. We need what first? X. Well, I can just flip them, yes? So what would it? How would I rewrite it? Negative 2x plus y is equal to 1. So we're not using that anymore. Because since the negative is in front of the 2x, we take it with it. Since it's minus 2x, well, that's the same as negative 2x. Is the other equation in standard form? Okay, so let's write the augmented matrix. So I will put one of the brackets. I won't put the second one just for spacing to make sure I have enough space. So let's list the numbers across the top for the first one. It would be -2 and then 1 and 1. And then I'll put the other bracket, try to make it so we do have enough space in there. I just I leave off putting the second one just so I know I have enough space to fit every number so that I don't put both and then have to squeeze everything in. How about the next one? 1, 3, 12. So we don't worry about X and Y for augmented. Just put it down. You're welcome. We just put the numbers. We just want the numbers. So in an augmented or in a matrix, we only have numbers. We do not put variables normally. If there is a variable, it's asking you to figure out what the value would go there. Now we just need the dimensions. So what are our dimensions for this here? This is how I remember down by over. So how many going down? By 2 by 3. Rows by columns. Rows by columns. Because our rows are the ones that actually go left and right. How many of them do we have? Well, we've got a top row, we've got a bottom row. Columns are the ones that go up and down. And I have 3 of them, so the dimensions is 2 by 3. Our augmented matrix is this here. Questions on this here? Harder than yesterday? Any questions on this here? Let's look at the next one. Are the 2 equations written in standard form? The top one needs to be changed to what? Equals 13. Okay. Now they're both in standard form, so how would we write them? And then? Yep. What are our dimensions? 2 by 3. That is it. Are we ready for the next one? Are all 3 equations written in standard form? -2z on the wrong side. We want all the variables on the same side. So I'll write it out here to the side. 3x minus 4y equals 7 minus 2z. So what can I do to get the 2z to the other side? We just need to add it to both sides. So 3x minus 4y plus 2z is equal to 7. We're not using that anymore. So now are they all in standard form? For the most part, yes, because we have x, y, z, x, y, x, y, z. So let's write the first one. So our first row would be next one. 9, 3. Since the second one doesn't have a z, we have to fill it in with 0. Now, we had to use it because the first equation and the last one both have a z. So we need a spot for z. Because if one of the variables shows up at least once in any of the three equations, it needs to have a spot for all three. Even if it's not there, we just fill it in with 0 for any that don't appear. Now, if we didn't have a z in the first or last equation, that's fine. I don't have to fill it in. But because one of them had a z, all of them need a z, even if it's just filled in with a 0. And that brings us to the last equation, which would, and this is a and these will show up on the test, just so you know. Now, I do grade these not too heavily, but I do grade them a half a point an element. So if you get one of the elements wrong, it's half a point. So if you leave this blank and don't put that in, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 6 points. So these do have some weight to them. That's kind of nice because you just need to fill them in. I do make sure that they are written in standard form. I did have someone ask me first hour, does the order in which we put these three matter? No. Because remember when we solved equations yesterday, how we could switch the order of the equations but still get the same numbers? The order in which we put these three doesn't matter. Okay? Let's look at one last one. Are these in standard form? That's nice. So this would be 5. And then 2, 1, 2, and it is a 3 by 4. In matrix, and we'll get into this more probably later, we can actually use matrix very effectively. Computers do use them to set grid numbers and reference points. And we can actually talk about each individual element. We won't do it here, but we will do it later on because we can talk about element 2, 1. Because here our dimensions are what? Row by column, yes? So if it's element 2, 1, it's row 2, column. So row 2, column 1 would be 2. And we can signify that. And I believe a lot of vending machines will do the same thing, set up each item as a grid, kind of like a matrix, and we can denote each item. It's a little loosely based, but they can be very helpful. I don't think we need to see more examples of how to write these as an augmented matrix and their dimensions. Solving systems of equation using technology. Many technology tools have a feature that you can use to solve systems of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, echelon, is shown below. Observe that the solution to the system is xyz equals negative 1.4, 5.2, and 16. We can verify this if we wanted to by plugging it back in to see that the equations do work out, like we did yesterday when we plugged in those values of A and saw that they did work. Now, one of the other reasons that we know that this is XYZ is, well, when we set it up in standard form so that X was first, Y was second, and Z is last, yes? So this first one, if I plug this back in, XYZ, well, tell me that I have X plus 0Y plus 0Z is equal to negative 1.4. Well, the only thing that's actually there is X equals negative 1.4. Well, the next one is 0x plus y plus 0z equals 5.2, and the last one, 0x plus 0y plus z is equal to 16. That's also why it's helpful to have it in x, y, z, because it kind of gives us the answer when we solve. Questions on this here? So let's see here. So these steps here are given to you. I did give these to you. So the first step is to write an augmented matrix for the linear system. Step 2, enter the augmented matrix into your graphing calculator. Step 3, use the reduced row epsilon form feature to rewrite the system. And step 4 is interpret the results from step 3 to solve the linear system. Okay. So we'll do this, and we'll do this together. So when we look at this here, we want to rewrite this system of equation in a augmented matrix. So it is in x, y, z. So our numbers for the top would be 1, 1, 1, 2, and then 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. Okay, let's grab the graphing calculator. Clear. So the first thing we want to do is put this matrix into the calculator. So we're going to hit second matrix. Second matrix. Now some of them will have a matrix already plugged in. It says A is 3 by 4. That means a matrix has already been plugged in. If it just says matrix A, it has A with brackets around it but nothing beside it, that means that it hasn't been defined. We haven't set anything for it. So we're wanting to do what to the matrix? We're wanting to input it in. We're wanting to do what? Anybody take a guess? We only got 3 things listed up there. We're wanting to edit it, yes. So let's scoot over to edit. Because here will let us input the matrix. It lets us edit what the matrix is. So we can go on and hit enter. And you should get something like this here. Probably most of y'all will have the exact same thing I have up here, yes? If not, that's fine. That means it just wasn't used first hour. Now we want to set the dimensions of the matrix. So we're going to do 3 by 4. And you can do 3, enter, 4, enter. If it's already set up as 3 by 4, we can just hit enter twice and it'll throw us down into the first row, first column. Now what we're going to do is we're going to input each element. And you can do that by hitting the number and then hitting enter. So you don't have to use the arrows. So I can go 1, enter, 1, enter, 1, enter, 2, enter. I've got the first row. And then we can do the second one, 2, enter, 3, enter, 1, enter, 3. And then 1, enter, negative 1, enter, negative 2, enter, negative 6, enter. And once you've entered in the last one, it should throw you back up into the first row, first column. So we want to enter all those in. Anybody have any questions on how we got to that point? Second matrix, edit, 3 by 4, and then we need to enter that in. Everybody at the same spot here, yes? Once you get the whole thing typed in, we're going to go second quit. Second quit. We want to quit out of this here because the next step that we do, if depending on how we do it, there's a chance that it's going to want to throw it back in here. So we are able to throw other functions and other features into the matrix. So using sine, cosine, tangent, or like we saw yesterday where I can pull y1 in. I can pull other things in. I can pull stuff from the catalog into this here. So if we don't quit out, it's going to throw it back into the matrix. So we don't want that. Like we don't want to have our next step RREF in here. We just want these numbers. So we go second quit, which will bring us back to the home screen. This here. Everybody, we're good? So second matrix, edit. So we went 1, so 1, 2, 2, 3, 1, 3, 1, negative 1, 2. No, you're right. You're good. So then we go second matrix. So our next step is going to be second matrix. Now we're going to go over to math. So this is some of our ones that we can use. And what we want to do is we want to scroll down to RREF, reduced row echelon form. And hit enter. So we have RREF. So we want that first because what comes after it is saying that we want to take the matrix A and put it into reduced row echelon form. So to get the matrix, we're going to go second matrix, not second math. Now, we won't go over to edit this time because we're not editing the matrix, we're wanting to recall it. And that's what this first row is recalling the matrices, or the matrices that we want. So I want the first one, which is already highlighted. I can go on and hit enter. So we have RREFA. Yes? Hit enter again. So what's our solution? Well, negative 1, 1, 2. That's it. That's all we have to do for this here. Questions on this here? We ready to do another one? Okay. Erase this here. Pull this back up. So our augmented matrix would be 2, 3, negative 1, 15. Then we would have 3, negative 9, 9, negative 12. And then we have 4, negative 3, negative 1, and 19. Two, 3, negative 1, 15, 30, 9, 12. So we can go on and pull the calculator up. I rewrote this down so I could have it. So what was our first step? Second matrix. Erase all that. So second matrix, and then edit, enter. Now since it's still a 3 by 4, the dimensions are still the same, we can just hit enter, enter, and go down and input the first row. And then we go over to edit and hit enter to put it into matrix A. And we'll have 2, 3, negative 1, 15, 3, negative 9, 9, negative 12, 4, -3, -1, 19. What do I do once I have the whole thing entered in? We go, second quit, and then second matrix, math, and then find RREF. And then second matrix, matrix A, enter. And our solution is 5, 1, -2. 5, 1, -2. And that's all we have to do for this here to solve it. Questions on this here? Good? We can look at one more. So looking at the other ones that we have on the note sheet, which one do we want to do next? Because we have 4, and I think we have 2 more on the other page at least. 4, 5, or 6, which one do y'all want to look at? All right, let's look at it. So here, we would say 3, 2, -5, -10. The next one would be 6, and then -1, 8, and the last one would be 1, 3, -2. So any spot where we have one missing, we just fill it in with a 0. So second matrix, we go over to edit. Now it's still a 3 by 4. So we have 3, 2, -5, -10, 6, 0, -1, 8, 0, -1, 3, and -2. So you got it all typed in. And go second, quit. Now at this point here, we've typed it in at least twice, yes? So watch this here. So I'd watch this here, so I'd stop wherever you're at. I can cursor up and highlight this, yes? Because we just renamed matrix A, didn't we? So we can actually bring that back down and do it again. So really, once we typed in RREF matrix A once, and as long as we keep renaming what matrix A or redefining what matrix A is, I can keep reusing that over and over again. Now, if we notice that there is a decimal in there, there's a decimal number for the answer. If we go math, have FRAC selected, hit enter, enter, it will change the numbers inside there to fractions for us. So that tells us that we have -2/3, -34, -12. Any questions on this here? Okay. So back to this here. New page. Now, there are two things that I want to highlighter. If you get something like this as your answer, especially with that bottom row, well, the first three numbers are our x, y, and z, yes? So it's saying this side of the equation is 0 and the other side is this a true statement? No. So what is that telling us the solution for this is? No solution. There is no solution that will work. And this setup here would be infinitely many. Infinitely many. And most likely it might tell you that the infinitely many might be invalid dimensions, but there's ways to get around that. But especially if the bottom row is all numbers and then you have a number, most likely we're talking about no solution. But that is all for today.